uncracked. Yeah. Why? Because this is a actually simplified calculation for deflection. And with all these assumptions, we will getting closer to the final and real answer. And we have to do this. If you have a negative moment for uncracked section, M crack, forget about the flanges in tension. You get it? Neglect tension flange. Neglect tangent flange. That's it. And then go to the next page and how we can calculate this stuff. I'm going to give you all the information. Okay, the first page mentioned that we have to find YT, Y bar, IG. Yeah, how can we calculate this? If you have a positive moment, so I want to find YT, IG, Y bar for M positive. How can I do that? Neglect the flange if there is any in the tension part. So nothing for that section. Then for Y bar, just you have to find, actually we did that on last week as well. Y bar, I just split this to two rectangular shape. As you can see, this X and this X, yeah? So area time moment of area times center of this area to the baseline. I will consider this as a base. Yeah. So center means TF divided by 2. So area times TF divided by 2. B TF times TF divided by 2. That's it. That's the first one. The second one, area means from here to the bottom. Let me answer the chat. Why is it called section? Yeah, because M crack, look at this, M crack is means moment that the beam can carry with no crack, means at very far end of the tension part in positive, tension part in negative, you will get close to that FR. The rest is under compression. So there is no tension at any point of this. It starts 0 here and maximum compression here. 0 here, stress, maximum compression here. So there is no tension. And because of that, we call that uncracked section. Did I give you the answer?
Yes.
Always when you ask question, I will ask you, did I give you, because I want to make sure that I gave you the answer. So if you are not happy with the answer and you are not letting me know, that's your problem, because I'm asking you. Yeah. And no problem. If you ask me 10 times, I will review that 10 times. Yeah. To make sure that you got it. Okay. So that's the Y bar. Go with the second bar. Second part is area of this part. Area of this is H, because we consider that for the first one, H minus TF, times BW, that's the area. BW, H minus TF. Then from center of this to that part, center of this is H minus TF divided by 2, because that's the center of this rectangular. H minus TF divided by 2 is from here to here, plus TF means to the H minus TF divided by 2 plus TF. Then divided by total area, B times TF, H minus TF times BW. That's it. That's the Y bar. But YT is to the tension part. So this is the neutral axis. To the tension part is YT, and we need YT as well. So H minus Y bar is your YT. What's the IG? All these are from statics, is not from must know all these stuff. I'm refreshing your memory because it was a long time ago. You might not, you cannot remember this. Yeah. So IG, as you might remember, you should go with sigma IO plus sigma 82. IO means moment of inertia around its own axis. So this section about this axis, this section about this axis. And we know that about this axis, B, this one in the power 3 divided by 12. This one, B, your B for this rectangular shape is this one. B times H means H minus CF in the power 3 divided by 12. So you can see BTF 3 divided by 12, BW times H minus TF divided by 3 in the power 3 divided by 12. These two are sigma IO. Yeah. moment of inertia of these two sections around their axis, not around the whole section. No, about their axis. This one about this, the other one about this. If we have another rectangle, we have to add them together. Then plus sigma area times distance from center of each section to the center of the whole section. So area of the first one, B times TF, times distance from center of each area to center of the whole section, means from here to this neutral axis. That distance, how can we calculate that? You can do by your method. It's up to you how to calculate this actually distances. Yeah. So anybody can come with any method that they want. Yeah. So I can go with y bar minus half of this, because center to this line is y bar minus half of TF. So B times TF, y bar minus TF divided by 2. That's it. Can see very easy. These are very easy, especially I gave you the equations. When we have the regular semester, I'm not giving these equations to these guys. Yeah. So I'm just solving one example, and then if you have question, you will ask me, because you are very close to the graduation. Yeah. So you should go after all this stuff. If I am giving you all this stuff, sometimes that's not good idea, because you should learn how to catch fish. If I give you always the fish, you think that's it, but no, our real life is not that easy. All of us, we have very hard life. It's not easy life. And because of that, I'm trying to give you something, but still, please go after them and do it by yourself. Yes, what's the question?
Where is D calculated from?
D, look at this. Over here, we have no, okay, this D is not the same D that we are considering for rebar calculation. This D means distance from center of each part to neutral axis of the whole section. So the first area is this one. Distance from this center to this line is the D for this section. Second one, this cross section, distance from this center to this neutral axis is the new D. So if I call the area 2, D2, area 1, D1. Is that clear? Look at this. This is D1, y bar minus TF divided by 2. And this one is D from here plus TF up to top minus y bar. Yeah, look at this. H minus TF divided by 2 means up to here. Plus TF, then minus y bar will give us this distance. This D is the distance between each area, central to the neutral axis of the whole section. That's the meaning of D. Sigma means how many parts we have. We have two segments, segment 1, segment 2. So we have segment 1 and segment 2. Area times distance in the power 2. Distance means from here to here, H minus TF divided by 2, plus TF minus y bar. That's it. Did I give you the answer?
Yes, thank you.
Welcome. Okay, another question. What's the question?
Yeah, so what's actually, so what's the difference between Y bar and YT? Like, what are those?
Look at this. Y bar is neutral axis to the compression side. YT is the neutral axis to the tension part. That's it. That's the difference. Nothing. Those are distances from neutral axis. Did I give you the answer?
Yeah, thank you.
Okay. Okay. Any other question? Okay, just let me know whenever you have question. Stop me. I will stop because I don't want to go too far. Then you problem here. If you have problem here, stop me here, please. Okay, let's go to the next slide. As you can see, it's very easy. Yeah, just follow these equations and just I will ask you, imagine I'm going to use this for a rectangular shape that is like this with this shape. Yeah, how can I use this equation for that one? Look at this. Please pay attention to all this. Write note for yourself. because right now you think you got it. As soon as you go and to do your work and you have a family problem, I don't know, any of us, we have a lot of stuff. So in that case, you will forget. But if you want to use this for rectangular shape, because this, I gave this one because it can cover everything. So in this case, your TF should be 0. Your TF should be 0. That said, put TF 0. TF0, 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 TF0. That's it. That should be good for rectangular. But in that case, B times TF, you will get nothing. It means that that B is not there because you don't have T. Your B is BW. As you can see, you will get 0 up here, 0. Anything with B and TF will be gone. So there is no B and TF on that part. I hope I gave you all this information so you can use them correctly. Just if it's for rectangular, don't do anything. Just TF is equal 0. That's it. TF is equal 0. TF times B, you will get 0. But BW is this one. H will stay the same. Look at this. H is from bottom to the top. TF is 0, but H is H. So you have this rectangular shape. Yeah, whatever it is, you call that B for rectangular, BW, and use that here. Or using this equation, consider TF equals 0 because there is no flange on top. For the bottom, always flange 0 because you remove that section, neglect that, and all in this equation, there is no effect of the actually bottom part flange because we consider them 0. That's easy to use always. Okay, let's go for negative. If we have negative moment and we are going to find y bar and yt, as you can see, the same equation, yeah, just you rotate that 180 degree. So this is the base, the distance, this area times this distance, exactly the same as the other one. The second area, this area times center to this part, divided by total area. That's it. But these are for negative moment, and this one is IG for negative moment. As you can see, we neglect the flange on top because it's negative moment means tension on top. Yeah, so as you can see, nothing new on this one, exactly the same, just the shape rotated 180 degree. That's it. And we consider this y bar here, yt to the tension flange. For the other one was to the bottom because tension flange was at the bottom. Okay, that's it. So nothing new on this one. Then I have to calculate the neutral axis and moment of inertia for the, so I have to calculate I crack. So first of all, let me back to this one to give to make this complete. I want to make sure that you got this completely. Based on this, I calculated y bar, yt, ig positive. I calculated yt, ig negative. What does it mean? Based on this slide, yeah, we can calculate m. So FR will be same because nothing is new. FRMC is for positive moment, negative moment is always constant. FR is the same. But IG, if you use IG for positive, YT for positive, you will get M crack for positive. If you use IG for negative, YT for negative, you will get M crack for negative. I hope it's completely clear. Yeah, FR no change. IG, as you saw, we calculated YT for negative, Y bar for negative, IG for negative, YT for positive, Y bar for positive, IG for positive. Sorry about that. I think I lost you guys for a few seconds, and but hopefully right now you can hear me. Can you hear me now?
Yes.
Yeah.
Okay, perfect. Yeah, because it completely disconnected and then connected by itself, fortunately. So I will repeat this one more time. For positive moment, I am to calculate M crack for positive. In this case, use IG for positive, YT for positive. I want to use calculate M crack for negative. Use IG for negative, YT for negative. That's it. So you can find M crack for any negative and positive moments that we have. If we have two negative, one positive, you have 3 M cracks. If you have just one positive, you have 1 M crack. If you have one positive, one negative, then you have 1 M crack for positive, 1 M crack for negative. So during the rest of this an example, you will learn how to use this stuff. Okay, so then we have to go with the crack section because we know that the beam will be cracked under load. So in that case, we have to calculate the I crack. IG was a moment of inertia without crack, yeah, for the gross section. But this one is moment of inertia for the cracked section. Okay, so how can I calculate this? That's for M positive. If you have M positive, always compression is on top, tension at the bottom. If you have M negative, tension on top, compression at bottom. So these green dots that you can see, it means that concrete is under compression. So it's still we have concrete. The rest part is cracked. So the concrete is completely splitted. Yeah. So there is no compression here, nothing. Imagine it's air here. Just we have rebar in compression, concrete in compression, rebar in tension. That's it for positive moment. The rest, the white part, we have to neglect this because it's cracked already. Yeah. Another part, if we have positive, negative moment, so compression at the bottom, so concrete in compression, rebar in compression, as you can see, rebar in compression, A prime, rebar in tension, AS, rebar in tension, AS, in compression, A prime. As you can see, just 100-degree rotate this one, you will reach to this. That's it. So, and we have to find Y bar for positive or Y bar for negative. What's the Y bar? Neutral axis of the cracked section. Neutral axis of the cracked section. Okay, let's see how can we calculate this. And it's not that easy because this Y bar can be inside the flange or can go inside this. If the moment is not that big, this neutral axis will go to the web. So we have to calculate that in another way. So I wrote all the equations for you guys. Just please read this and try to understand and solve examples with this. This is from your side, yeah? So please do it. Then at the time of exam, you will be fast. But even if at the time of exam, that's the first time you are going to plug in the numbers, it will take time forever. And in future, you don't have that time. So you have to do a lot and make yourself ready for the exam. Then you can see how fast you can go. And you will enjoy and proud of yourself that you can go that fast. So for this case, for M positive, I want to find Y bar and I crack. Let's see what should I do? Because I don't know if the Y bar meets neutral axis will stay inside the flange. If there is any flange, maybe it's the rectangular shape, then don't worry. Don't worry. You can use either of these two. But if you have flange, then follow this instruction because we don't know if the neutral axis will stay inside the flange or will go inside the web. What can we do? At first, we assume that Y bar less than or equal TF. That's our assumption. Then we will check, because you calculate this. If your Y bar is less than Y bar TF or equal TF, that's good. Keep going. If it's not, then this is wrong. This part is not acceptable. So go with this one first. Assume Y bar less than or equal TF means here, as you can see, it can go all the way to TF, the same equation. Then how can I use this Y bar? Do the same based on the baseline. Moment of area, the same thing, but here we have one concrete and this shape, one steel, another steel. For a steel in compression, because this part is part of the concrete as well, we have to reduce that part. Yeah, because I consider the whole section concrete, but part of that is rebar. So I shouldn't consider that twice. So I will go with n minus the n. N is a factor that will actually transfer, or it can convert the rebar to equivalent concrete. That's it. How can we calculate that? ES, modulus of elasticity of a steel, divided by modulus of elasticity of a concrete. That's it. Find that n. Then n minus 1 times total cross-sectional area of the compression rebar. For example, you have three number 9 rebar. Each number 9 is 1 square inches. 3 times 10, 1 means A prime S is 3 square inches. Find n, for example, n is 8. Yeah, 8 minus 1, 7. 7 times 3 is this number. That's it. For this one, n times AS for number 9, for example. So 8 times 4 square inches, 4 times 1 square inches. So you can calculate these two. As you can see, we have all the numbers. B, we know the size of the beam. D, what's the D? Distance from center of the tension bar to the top. D prime, center of the compression bar to the top. It's the same as rebar calculations. Yeah, nothing is new here for this section. So based on this, we have 3 segments: 1 concrete, 2 rebar. Area of the first part means that B times Y bar. Look at this, B times Y bar times Y bar divided by 2, because half of this distance, Y bar divided by 2, plus area of this one, n times AS, times distance, yeah, times distance, n times AS, times distance to that baseline, n AS times D. Then area of this times distance times D prime, n1 minus 1, n minus 1 A prime S times D prime. So the same as before, same concept. Moment of area, area times distance, divided by total area, by bar, n minus 1 A prime S, n AS. That's it. Calculate this Y bar. Then, for example, you calculate this and you got 3.2 inches. And your TF was 3 inches. So it means that that was wrong assumption, because Y bar is not less than or equal TF. If it was equal or less, you are good. But if it's not, it means that forget about this, go to the second part. Do not continue if you got Fy was not less than TF. I wrote that if Y bar was less than TF or equal, then or equal, less than or equal TF, then go after this. Otherwise, stop and go with this one, because Y bar was not less than or equal TF. I hope it's completely clear. Assume this, find this, check it with TF. If it's less than or equal, perfect. Fine, I crack from here. If it's not, forget about Y bar thing. Go and recalculate bar. Look at this. We have another equation for Y bar. But at first, imagine this one correct. The Y bar was less than or equal TF. Then how can I find this? The same equation, sigma IO plus. And here, just remember, rebar IO is too small. Neglect that always. So in that case, we have 1 concrete. So IO for that one, B times height in the power 3 divided by 12. B y bar 3 divided by 12. But sigma IO for the rebar, forget about that. It's too small. We assume that's 0. IO for this rebar, 0. As you can see, there is no other y bar IO. We have just one IO. The rest are A D square. Okay, A means area of this. B times y bar, yeah, B times y times distance to the neutral axis. Neutral axis is y bar. Distance to neutral axis is y bar divided by 2. Yeah, for the first part is exactly the same. So area times distance from center of this part to the center of the hole. So, okay, those are the same. Center of the hole is here. Distance from that center means y bar divided to this one is y bar divided by 2. That's it. Plus n times AS times distance to neutral axis means d bar minus y bar. Yeah, look at this. D, not d bar. D minus y bar means distance from this line, neutral axis, to tension bar. So N A is times D minus y bar square, D square. Yeah, just remember this D is not this D. That's a little confusing, but that's the way that we know this equation from statics. Yeah, but just remember this D is distance from the any part yeah, distance from any segment to the neutral axis of the whole, this D. But that D or D prime is distance from neutral, from tension bar or compression bar to the compression concrete. Okay, so, and for the other one, area n minus 1 times a prime s times distance to y bar, distance from this center to here. So should be y bar minus d prime will give us center of this to the center neutral axis of the whole section. Yeah. So y bar minus d bar squared. That's it. That's it. But if y bar was greater than TF, what should we do? Forget about this. Stop at this part. Don't actually waste your time to calculate this because it's not worth it. You don't need this. That's wrong. Come to this part. Find y bar. So how can I find y bar? This y bar is based on two. In this case, y bar is not inside the flange because we checked that. Yeah, it's not inside the flange. It should be inside the web. Okay. So how can I calculate this? I have two segments of concrete. One this part, another this small part, and two part of the rebar. So we have 4 segments. Yeah, as you can see, we have the first one is B times TF times distance to the top, TF divided by 2. B TF times TF divided by 2 plus. Then what's this height? Y bar minus TF is from here to here times BW, Y bar minus TF times BW. That's the area of the web, this part, yeah, times center of this to the top means Y bar minus TF divided by 2 means from here to here plus TF. As you can see, Y bar minus TF divided by 2, yeah, Y bar minus TF divided by 2 plus TF. That's it. So that's for this section. Please try to rewrite this by yourself based on the parameter. In this case, you will understand completely. Yeah, please do it. So, and then n minus 1, a prime s, this distance, all the way to the top. Yeah, so this area times distance to the top, n minus 1, a prime s, d prime 1. Then area of this, NA times distance to the top, divided by total area. That's it. Yeah. So for sure, when you calculate this y bar is greater than TF. If it's not greater than TF, so you did something wrong because you check it's inside, it's not inside the TF, and this one should be out of the TF. Yeah. So you can calculate y bar from one of these two. and then go and find I crack for this section. How can I do that? We have IO for 2, IO for this rectangular section, IO for another rectangular section, IO. Then A D square for this one, A D square for this one, A D square for the rebar, A D square for this rebar. Yeah, that's it. Yeah, you can see everything is completely clear, and just follow the instruction and you will not lose anything. But for sure, it needs a lot of work from your side. It's not done. Yeah, I can give you the information. In some actually schools, they don't like this method. They like send you after this. They come here for 20 minutes. They give you, okay, the concrete, the crack will be considered for this, and go and read chapter, for example, 6. That's it. If you have any question, next week ask me. But my method is not like that. I like to transfer everything that I know to you guys, but then ask you to go after it and do it. Because right now you have something, you have some base, so you can go faster. I think it must work better. Hopefully that's correct. So imagine I want to use this for rectangular shape. What should I do? Just remember, I want to check to see how can I use this for rectangular shape. So what can I do here? As you can see, there is no TF in this one. So how can I say no TF here? In this case, B, look at this, I have one B and BW. In this case, your B should be equal BW. If there is no flange, your B is equal BW. Just change this to BW. That's it. No change for anything else. Put a note for yourself. Please, these are important. You can get this if you recalculate this stuff by yourself. But right now, I'm telling you, write a note for yourself, then you will not be lost at the exam or whenever you have a PA exam. My exam is not that important. If you fail, you can retake that. Yeah, for PA exam, you have 2 or 3 times and then you can't do that. So you will get problem with that. 1 minute for that. You must be fast. 1 minute for each question. I give you 25 minutes. You shouldn't say, okay, this is not time. No, you must do it faster. And I will encourage you guys to reach to that point. So in this case, going to use this for the rectangular shape. So in this case, your B is equal BW. That's it. So for that, which of these two is good? If it's rectangular shape, should I go with this or with that one? Both of them will give us the same answer. So which one is easier? This one. So go with this. Remember, for your PA exam, if you are going to calculate something like this and it's rectangular shape, so go with this one. You can see you have less parameters. Here you have a lot. Don't waste your time with this. Yeah, this is good for I shape, for T shape, or something like that. If you have rectangular shape, means B is equal BW, go with this. If you do with this, you will get the same answer. So don't waste your time. In this case, you should consider TF is equal 0 as well. Okay, so this one will actually make problem for us. If it's rectangular, go with this. Okay, let's go after this part. I crack and Y bar for M negative. Look at this, up to here was for M positive. How can I know that? Because compression in concrete on top means M positive. Yeah, on top, M positive. Compression at the bottom, M negative. Even if I'm not telling you if it's for negative moment or positive moment, you should know now. Whenever you have compression at the bottom, it's negative moment. Compression on top, positive moment. Do the same. Just 90-degree rotate this. Again, I assume that Y bar is inside TF. Look at this. On negative, positive moment, I consider on top. On negative moment at the bottom, do the same. Nothing is changed. Nothing is changed here. Yeah, just go with this one. Okay. So if I so in this case, if I am going to use this, if you want to use this one for rectangular shape, yeah. So in this case, your TF is equal 0. You can see TF is equal 0. Nothing here. TF is equal 0. BW, just this. Go with TF equals 0. If you are using that, there is no TF. Go B is equal BW. Yeah, B equal BW. You are done. You can calculate based on both of them. And as I mentioned, for sure this one easier for rectangular shape, and you don't need to do anything. Let me ask one quick question to see if you follow me well or not. Okay, I am going to calculate. This is my question. Please listen and try to find the answer as fast as you can. I'm going to calculate the moment, this IG, YT for rectangular shape. So that's for uncrack. How can I calculate this Y bar? The fastest way. For uncracked section for rectangular, that's H. That's the height of this is H. That's a P exam. You have 1 minute, less than 1 minute. How can you find Y bar or YT for rectangular shape? See, you need 1 minute and you should connect your information very fast. Yeah, very fast.
0 for TF.
So so it will take time to go with this. The answer is half. H over 2 is your Y bar and TF is Y bar divided Y bar equal T YT is equal H divided by 2. That's it. That's the answer. You don't need to calculate this. For rectangular shape with uncracked section, your neutral axis is at the center of the beam. That's it. Yeah, you can calculate with this. You can see it's H over 2, H over 2. But you don't need to calculate that. Connect your information. Yeah, so this is just one example that you must connect. Okay, so we calculate this one as well. Then what should we do? Then the seventh actually step. The seventh part is, let me go and plot something. I have to plot something. Imagine for a continuous beam. Yeah, assume this is a continuous beam. It's hard to plot with this pen, but I'm doing it as good as I can. Yeah, so this one, and this one. Okay, so imagine I'm going to calculate this for this span. See, in this span, negative moment, 0. Positive moment, negative moment. I have 1 positive moment, 1 negative moment. For this case, I have 1 negative, 1 positive, 1 negative. This is the most case that you might see in future in real structure. We have frame. For frame, you have 2 moments negative, 1 positive. So you have to calculate 2 M crack negative, 1 M crack positive. 2, not this one, 2 IG negative, 1 IG positive. Yeah, 2 I crack negative, 1 I crack positive. So we have to calculate all these stuff. So for this case, 1 IG positive, 1 I crack positive, 1 M crack positive, 1 M crack negative, 1 IG positive, 1 I crack positive, negative. This part all negative, this part all negative. Positive, yeah, positive, negative. So based on all those that I mentioned so far, we have to calculate the effective moment of inertia, because we calculate a lot of moment of inertia. IG positive, I crack positive, IG negative, I crack negative for both sides. So how can I find which one is the moment of inertia for deflection calculation? None of them. This is the equation that we can use and find the moment of inertia, effective moment of inertia for positive and negative. How can I do that? Okay. So based on the moment diagram, let me, I have to plot this one more time. I will go just with that case that we have. I will call this actually unfactored moment. Yeah, m-1, m-2. I like to see you are taking notes because these are the things that you might need them. M positive at here. Okay, so for this one, M negative, we calculated M crack for this side based on the rebar and everything that we had. Yeah, so we have that M crack. MA is this one, not with sign, with no sign. Yeah, just MA. So M crack divided by MA, maximum moment at this side. Forget about that side. Even that side is bigger, doesn't matter. We have 2 negative and 1 positive. So we have to calculate 3 IEs. Okay. For this negative, use M crack for that negative divided by MA is this moment, whatever it is, times IG for that uncracked section that we calculated. Yeah, IG for uncracked section plus 1 minus M crack for that negative divided by MA, the same, in the power 3 times I crack for that negative moment based on the rebar that we had. You can remember we had AS negative, AS positive for moment, negative moment for this side. So we have all those numbers. Calculate this. This one is your IG. Let me write this here. IG, IE, -1. Yeah, based on this side, I calculate this. And I told you MA is this number. Forget about the sign. Yeah, M crack we calculated. IG everything we calculated. Then go after M positive. For M positive, go with M crack for positive. We know that. Okay, we have this. MA positive, maximum positive moment, whatever it is, the same unit, just remember. If it's inch, or doesn't matter because that's moment, keep inch, or keep foot, doesn't matter. This one should be inch in the power 4, inch in the power 4. This one can be keep foot or whatever you want because this actually has no unit. M divided by M has no unit, so it's not that important. So MA is this maximum moment positive. IG for the positive moment. I crack for the positive moment based on the rebar that we have here. Calculate this, find IE positive, consider this IE positive. Then do the same for other side, IE -2. Yeah, that's it. So I find 3 IEs. So what should I do with this 3? In order to calculate 1 IE, that's the final calculation. Okay, 50% times IE positive. IE median means IE positive. Yeah, that's the positive part. 50% of this plus 20% of this one and 25% and this one, or 25% at total, doesn't matter. 25% of the negative moment at one side, 25% negative moment at other side. If those two are the same, moments are the same, the rebar at both sides are the same, so you just need to calculate one of these, yeah, because both sides are the same. You have the same moment, the same rebar at both sides, top rebar, bottom rebar. So don't waste your time at the time of exam. Just calculate 1 IE and then write IE -2 is equal I -2 without any calculation because everything is the same. Then when you go here, those two are, if this is 0, it's the simplest opportunity. You have 1 positive, 1 negative. So in this case, 75 and 25% of that one. So how can do that? So any question on this before I go to other page? Any question on this?
Professor, can you repeat when you said
Good
the
class.
exam? Or
Oh,
you,
I will go to the other side. At first, I want to make sure you got this. Then I'm going after that. I will let you know completely. Any question on this part? Okay. Actually, look at this. This is a good class. I like this class. Most of the time, in all my actually 30 years of experience of teaching, especially during the past few years that I can remember, most likely in this course, most of the time on the first exam, I had a lot of bad grades, very bad grades. In this class, I did something else, and I hope I can see even better than this. Yeah, I like to see better than this. Please do your hard work and just be patient and make sure that with hard work you can be a good engineer. That's it. That's the only way. The only way. Okay, one question. What's the question?
So when do we know to choose the first equation versus the second equation again?
You are talking about this equation, i.e.
Yeah, because they're both IE, so I was just wondering when
No,
we.
you are talking about these two, this i.e. and this one.
Yeah.
Now look at this. Based on this one, you can calculate effective moment of inertia at the left side, effective moment of inertia at the middle, effective moment of inertia at the right side. Left, middle, right. The first one will give us 3 IEs that we need. The second one, based on those 3, you can find just 1 IE, because for deflection, we need 1 IE, not 3 IEs. I can't use 3 IEs. How can I use that? Go to this equation and just find 1 IE out of 3 IEs. Did I give you the answer?
Kind of. So do we use the first one to help us get the second one then?
Sure.
Okay.
First, we need this to find IE -1, IE positive, IE -2. Then with these 3, we'll go to the second one and we can find just 1 IE.
Got it.
Got it?
Yeah, I got it.
Perfect. Okay. So let's go to the second one and I will give you more information out of that. See? Okay. If you have one continuous beam, so in this case, the moment diagram, you will get 0 here because it's simply support. Yeah. No negative moment, no IE -1. No. So you have IE positive, IE -2. That's it. But for this one that you have negative and negative, IE -1, IE -2, IE positive. But what for simply supported beam, you have just 1 IE is equal IEM. That's it. You don't need to go to this equation anymore. Just you have to go to this equation, yeah, and find that IE. That IE is your final IE because there is just 1 IE. So there is no need to combine different IEs to find 1 IE. If you have just 1 positive moment, that's it. This equation is your final one. Will give you the final IE because you have just 1 IE. As you can see on this slide, I put all these notes to make that completely clear. If you have this beam, you have no IE1, IE positive, IE -2. IE -1, IE positive, IE. Keep going. For this one, no negative. So you have just one answer. The first equation will give us the final answer. When we are going to use the second equation, this one, when we have multiple IEs, yeah, when we have 1 IE, that's it. That's your final. If you have IE for negative, IE for positive, IE for negative, what can I do with that? Go to this equation. Okay. Is that the only equations? No. If your span, look at this. In this span, I wrote that for span AB, you have 1 negative, 1 positive. So between these 2 IEs, your final IE is this equation. Yeah. So you have 75% at IE positive for this one, plus 25% of that one. That's it. For BC, the same equation as the other page that you saw. 50% of the positive plus 25% of this plus 25% of that one. That's your final IE. For the frame that has rigid connections, as you can see, you have negative, positive, negative, negative, positive. So all of them should be considered as BC, yeah, because you have 2 negative, 1 positive, 2 negative, 1 positive. So for frame analysis, always this one. I hope it's completely clear, because we should understand this stuff, and then it should be easy. It's not that hard. But at first, yeah, those are weird, and because that's the first time you hear this stuff. But with reviewing this, repeat, it should be clear. So, any question on this slide?
I got a question.
Yes.
For
What's the
span,
question?
for span AB,
Yes.
is it always the case that the positive moment is going to be 0.75% of 75%?
Always positive 75%. If you have this case, you have negative moment just at one side. Always. There are different actually papers that if in future, if you like to write papers, and as I mentioned, I'm reviewing papers for ACI journal. So I see a lot of different equations, and in the book they mention different equations as well. But based on the code, we will go with this. The others, they have some yes and no, yes and no. But based on this class, based on the ACI code, we will go always with this. When you have just one negative moment and positive, this is your equation always. 75% of the IE for positive always, and 25% of the negative. Why? Because most of the beam length is under positive. And because of that, we are considering this the most. That's the reason. A small percent of the beam is under negative moment. And because of that, if you have both of them, 25%, 25%, 50%. It means that 50% for negative, 50% for positive. As you can see, 50% positive, 25 plus 25, 50% for negative. In this case, 75% positive, 25% negative. Simply support 100% positive. Yeah, so there is no need to combine anything because there is no negative. That's clear? Did I give you the answer?
Yes, sir. Thank you.
Perfect. Okay, so let's go. These are different equations. I'm not going to explain this stuff for you. If you want, you can read them. These are some other actually suggestions. So I'm not going to make you confused with this stuff. If you, in future, you like to learn more, if you like to write paper and you are doing some research, then these are good for you. But right now, for this class, just these two equations, these three actually, simply support, one side support, two side negative moment. That's it. Always this slide will give us all the answer that we want based on the ACI. This is just for your information. Okay, so, and then I wrote all the time for you guys, step by step, what should you do, what should you do, what should you do. That's it. Everything that I mentioned, you can see here. Okay, then after this, after you calculated this, i.e., yeah, based on whatever situation that you have, one negative moment, one side, two negative moment, or even no negative moment, then there is no IE. That 25% will come to here. You will get 100% of IE. Means IE is equal IEM. So you have just one IE. Is at the end? No, unfortunately. Deflection is very hard in reinforced concrete design. It's very hard. It's not like a steel beam. A steel beam is easy. You have one moment of inertia. That's it. Not cracked section, uncracked, negative part. Everything is the same. So it's very easy. You have one equation. But here it's not that easy. So for the long-term deflection, what can we do for the long term? we have to calculate the multipliers, long-term multipliers. That's the equation, always. What's rho prime? That's the just at mid span only. Just remember, forget about if you have negative moment, positive moment, forget about all those stuff. In this equation, rho prime is at the mid span only and should be compression rebar at mid span divided by BWD. If your T section, whatever, doesn't matter, BW, forget about that B. Rectangular is always B is BW. T section, I section, whatever, go with the web width times D. A prime S at the mid span only, yeah? Then time dependent factor for sustained load, yeah? How can we calculate that? That's the actually equation that you can see here. That's the system that we can go with this and find based on the duration of the load, what percentage you should consider for time-dependent factor. And it has to do with creep. You might remember the first day of this class, I mentioned that creep is very important. Creep means concrete under compression for long time. So it will change the size. It will reduce the size during that time under compression. So if you are putting the element under compression for a longer time, you can see based on 3 months, you will get this factor. For 24 months, you will get this factor. 48 months or 60 months, it will increase that factor. Yeah, so it has to do with that system. So over here, this one is another equation you can see based on they changed that lambda delta to this one. But if you go with that one, I will accept that and don't worry about that. This is a new version for that. Yeah. So instead of that lambda delta, they will go with mu times this one. And how can you calculate that mu? Is 1.4 times minus F prime C divided by 10,000. So it should be PSI. 4,000 PSI divided by 10,000 means 0.4. 1.4 minus 0.4 means 1. 1 times this, 1 times this, you will get this equation. So if your F prime C is equal 4,000 PSI, this is the same equation as this one. If you will get better, actually, F prime C, your mu is less, so you will get actually less lambda delta. So that's because of that, that factor, that multiplier is important. So either one, if you go with either one, I will accept. Just remember, if you're following the actually higher code, this is the one that you should learn. Yeah, but as I mentioned, for F prime C 4,000, you will get the same equation as that one. Okay, so how can we use all this stuff? This week, I'm not going to make you tired. Right now, you have to congest all this stuff. Work with all this stuff. Please do it. Go and put all those BWB, all those stuff that I wrote here. Please, from a start, go with all this stuff. Then cover this and try to find y bar based on the equation that based on moment area. Then check your equation to see if you can find this equation by yourself or not. You must be able to do this in future. If they gave you another beam, this TF is not the same as this TF. So what can you do? If they don't give you this shape, if they give you triangular shape, what can you do? You have to follow the instruction for the moment of area, that you can do whatever you want. You know what I mean? So I gave you one of the hardest part, because most of them in the classes, they are covering just rectangular. I gave you one of the hardest part. Then you can see this. And based on this, you can see if you have a triangular shape, how can you go after it? What's your approach? So you have to follow this instruction, not this equation. You have to find new equation. If those TFs are not equal, you have to find new equation by yourself. How? Just start from the basis. find the base, moment area about the base. That's it. That's it. If you understand this, that's the basic problem. If you use this stuff, as soon as change the shape, you can't do. What should we do? Go and start from the base. Find the equation by yourself, then you understand what does it mean. Not just plug in the numbers here. It's not, one high school diploma or even less than that can do that. That's not engineering work. Engineering work is finding these equations. Yeah. Otherwise, you will act like a calculator. Yeah. Calculator is not engineer, and you are engineer. Okay. So please do this. And the next week, I'm going to example, and you can see all this stuff on that example. You can see all the connections. And today I add this one for you guys as a classwork to see if you can solve this or not. Yeah, please spend a few minutes on this one to see if you can solve this problem and calculate MCRAC. Yeah, and here I gave you just A prime S and AS. What does it mean? Compression bar on top. It means that this one is for positive moment or negative moment.
Negative moment.
Negative moment. Look at it. Negative means tension on top or compression on top. Negative moment.
Doesn't that mean tension on top? Tension on top.
Tension on top means negative. But if it's negative, it should be AS, because tension bar is AS. A prime S means compression bar. So is this a negative moment or positive moment?
Positive.
Positive. Why? You have compression. Look at this. This one will give us the compression. A prime is for compression. AS. So I didn't put any note here because your eyes should see everything fast. Yeah, you need that for your PE. You need that for your work in future. You must be fast. They are not giving you as long as it takes. No. No, you must be fast. How? Do it 10 times. Then you can see how fast you can see this stuff or do this stuff. Please start working on this. And even not to completely write that down, or if you can write it and send that to me, perfect, or just do it for yourself, because I consider this as a classwork to see if you can use these equations. Start, please, and go after calculating MCRAC. I missed something here, please, just because I did that just today, 10 minutes, few minutes before the class. Please consider this 10 inches, BW 10 inches, yeah? Please just add this to this one. You know BW. BW is 10 inches.
Hello, Professor. I got a question.
Yes, what's the question?
Sir, for the crack section, the formula to calculate y bar.
Okay.
For the first part, where we assume y bar is less than TF, so I see that within the equation of calculating y bar, there are 3 other y bar as serve as a variable. So what is that y bar? Is it the same y bar that we're calculating?
Look at this. Let's go back to this one. You're talking about the y bar for a crack section or uncrack?
Crack
For
section.
crack section. We are here. Look at this. Look at this equation. You at first you assume that y bar is less than TF. Yeah, and TF is 5 inches. Okay, go on this equation, and you know B is 30 inches. Y bar is less than, we don't know, we have to calculate this. And you should consider N, you can go with N equal 8. So, and based on this, you will get an equation based on Y bar square. So you will get a quadratic equation, and you have to calculate it and find Y bar. Did you reach that equation?
Yes, I think I'm trying to work on your problem. I think that's the one that we apply. I did it wrong on crack, and I think the proper one to be used is the crack section.
So actually, which part do you think you actually made mistake?
I use the formula to calculate y bar of the uncracked section.
On for uncracked section, yeah. No, you can't use that. Uncracked section, that Y bar is just good for M crack. That's it. Do you know what I mean? For this one, you can just use this Y bar equation for uncracked section. And then when you go to the crack section, you have to recalculate Y bar. That's another Y bar. You have to go to this one. Is that clear?
That's where I did my mistake. Thank you.
Okay. So that's why actually that's good, because you just started, and making mistake is not that big deal. With this mistake, you will learn. That's good. So yeah, for uncracked section, you have 1 by Y bar based on this one. Then for crack section, you have to go to this one for M positive, find this Y bar. As you can see, you have Y bar unknown and Y bar unknown at this side. You have Y bar at both sides. So you will get a tick equation. Then you have to calculate and find Y bar. You will get 2 answers for Y bar. One of them is negative, one of them is positive. Negative one is not acceptable. Go with the positive one. If the positive one is less than TF or equal or greater than TF, if it's less than, keep going and find I crack from this equation. If it was greater than TF, go and restart all over again from here and recalculate Y bar and find the correct Y bar. And then I crack from this equation. Clear?
Clear, Professor.
Perfect. So actually, that's it for today. Just
I had a question.
Sure. Yes.
How are we supposed to know N was 8?
Actually, I should give that to you, because otherwise I have to give you ES and ES and EC. But right now I'm adding those on this picture from on other computer, because I noticed I forgot to give that to you, because it's a classwork. So you can ask me and I can give you the answer. But because I'm going to post that on Beachboard, so I'm going to add those stuff in future, maybe next day, if you are going to work on this as a classwork, just for yourself. You don't need to post that to me, but at least you can find your problems. If you have any question, let me know, so it can actually give you a heads up for example. So you should consider n equal 8, or in exam, I will give you n, or I will give you ES and EC, then n is equal ES divided by EC. You can calculate that by yourself. I saw another question. Did I
And
give
then-
you the answer? First of
Yeah,
all,
then is that 2.5 to the bar, like how far the rebar is to the current wall? Is connected?
from the center, this is your D prime. Yeah, from center to the top and from center to here. So if you want to find the distance from here to the top, should be H45 minus 2.5 from here to the top. Yeah. Is that clear?
Yeah, thank you.
Perfect. Okay. I saw another question. What's the question?
Yeah, I was just wondering. So after we solve for y bar and then we plug in that y bar to the I cracked formula, I don't understand what MCR positive is.
Look
Like
at
the
this.
moment?
M crack positive is first one. First, you have to go and find it. M crack is Y bar, YT, IG crack section. On crack section means M crack for M crack. So how can you find this? You find YT and IG. Go to this equation, look at this. M crack is equal FRIGYT. Can you remember? I mentioned for go with IG positive, YT positive, and you calculate them. Yeah, you calculate Y bar, then YT for positive, and IG for positive. Plug it in this equation, you can find M crack for positive. That's it. Did I give you the answer?
Okay, I missed that. Thank you.
Okay, very good. So any other question? So please, I will, right now, you know the stuff that you have to add to this to for preparing yourself for the exam. So consider this BW10 and N is equal A, yeah? So add those to this, and I'm going to revise this and add those to this slide and fix that on Beachboard. And I will post it on Beachboard again, and I will let you know that I add those to on Beachboard. If you have no other question, that's it. Thank you for coming to the class, and you can go just that part that they have lab today, please stay. Thank you.